Alright, so let's talk about the increasing triple subsequence. So you are given integer array nums. You have to return true if you can fulfill the constraint. And this constraint is pretty straightforward. You can use in a brute force, but I don't recommend. The brute force is pretty straightforward, ijk, right? And then you check every single index, all the possible combination. And then you start in moving your k first, and then if you cannot find out the increasing subsequence, then you move your j and start in the same idea, right? And then if you cannot find it, then you move again, right? Then you cannot find it again, then you move your I, right? So this is pretty much it, right? So the problem is what you need to find out if there is the all of runtime complexity and then all of one for the space. And in this one, this is onto a cube, right? You traverse every single one of the possibility, and then to find out the increasing triple subsequence. So this is not good. So how do you actually get the most efficient way? So I'm going to just give you my solution, and this solution is pretty good and it's insane. I don't think about it, and someone find out. So I will have a min1 and min2 set to the max by default value, and then I will have a pointer for my nums, and then I will have to check if my num is less than or equal to min1. If this is true, I'm going to update my min1 to num. This is first if statement, and then if this is true, right, I update. If this is false, I go into my else if statement for the nums. It's actually less than equal to min2. If this is true, I update my min2 to num, right? So in this idea, right, you probably notice you find out the increasing two element, only two right now. And then if you want to find out the third one, then you are just using an else, and then you will say return true right here. This is because what? You check your first one, the first if statement, and the num is less than or equal to min1, right? And then you don't execute this if statement, then you go on the next if statement. Nums is less than or equal to min2. So you cannot find it, right? So you don't execute, right? Then you know this is the third smallest value inside the nums array, so you return true. So this is pretty much the idea, but I have to just walk through this algorithm with you. So I will say min1 equal to max, min2 equal to max. And here's my nums, alright, my nums pointer. So again, if nums is less than or equal to min1, I update my max, I update my min1, right? If this is true, I update my min1 to 2, right? So there's a reason why you're using less than equal. I mean, be more accurate, why you use equal. This is because if you have 1, 1, 1, 1, 1, they are not actually increasing subsequence. They are actually on the same level. So you want to use an equal sign to keep updating your current smallness, right? So the same integer is not allowed, right? And then you go on your next pointer for the nums, and then you see the first if statement, min1, num is less than min1, then update to 1, right? Again, move your pointer to 5, and then you see, okay, this time min1 is what? It's less than num, right? So you don't update, but the nums is what? Less than min2, so you update to 5. Then move your pointer to 0, right? Now this is get updated. Now you change another pointer 4, right? And this is 4. Then the last one 6. So you check your first if statement. Alright, nums less than equal to min 1. Is this true or no? This is 6. This is 0. This is false, right? So you go on the next one. Is nums less than equal to min 2? No. This is 6. This is 4, right? So you go on the third one, which is else. Then you return true, right? So you find out the increasing order based on the comparison, right? And this is not coincident. If you find out, if you change the number for 0, you are still going to return true. Why? 1, 2, 6. I mean 1, 4, 6. Sorry, 1, 4, 6. This is the order, and even though even though the logic look pretty complicated, but the answer is correct. So in min equal to integer dot max val, comma min 2 equal to integer max val, right? Traverse the nums array, and then using the comparison, if num less than equal to min 1, I update my min 1 to num. Else if num less than equal to min 2, I update my min 2 to num. Else I return true. I find out the third smallest, I think, and then I have to return false at the end. So this is why you have to keep track of the current smallest, the second smallest, and then the third smallest, right? So let me run it. Right, so this is the solution. So for the time, this is time, all of them, right? For the space, this is space, all of them. I mean constant, sorry. So constant for the space, all of them for the time. And this is the solution, and I will see you next time. Bye.